In this lesson, we will learn how Arduino works and install the necessary software. The Arduino platform consists of hardware and software parts. The hardware includes various Arduino debug boards such as Uno and Mega. The software part includes special computer software, Arduino IDE, which is designed to write code and upload it to different Arduino physical boards. The Arduino board is a small computer used for creating smart electronics with your own hands. This board has a main chip, a microcontroller, that only works if you tell it what to do. Throughout this course, we will program this chip and connect various other devices to it. Arduino is used to create electronic devices that can receive signals from various sensors that can be connected to it and control various actuators such as electric motors. Let's take a closer look at the Arduino board. The most important thing on this board is a silicon chip, that is, a processor that we will use as a microcontroller. Various radio components, connectors, and interactive components have already been installed around the processor to make it convenient for the user. For example, if the entire Arduino board is conditionally divided into several areas, then the upper left corner is fully responsible for programming the microcontroller using a computer. For that, the USB connector itself is installed in this area for convenient and quick connection. Next to the connector is another chip that establishes a logical connection between the microcontroller and the computer. Let's call this chip programmer. The remaining radio components in this area are installed as auxiliary elements for the operation of the chip programmer. It is worth paying attention to the LEDs marked as RX and TX. They serve to indicate data exchange. That is, when a signal comes from the computer via USB, the RX receive LED lights up. Similarly, the TX transceive LED lights up when the microcontroller sends data to the computer. Let's look at the bottom left corner. This area is responsible for connecting the entire board to the power supply. For that, a power socket is installed in this area for convenient connection to external sources. Note, it is important that the type of the socket fits. In our case, this socket is called DC005. For this socket, there is a power supply in the kit with a suitable 12-volt plug. It is recommended that the voltage of the external source be between 7 volts and 15 volts. Otherwise, voltage stabilizers installed near the connector will heat up and may fail. One of these regulators converts the input voltage to 5 volts and the other to 3.3 volts. These voltage values are needed for the operation of the microcontroller itself and some other sensors. After power is provided, the on indicator will light up, an LED indicating that the board and chip are turned on. In this area, there are also capacitors used to filter the input and output voltage. That is, if there are interferences or surges in the supply voltage, then the capacitors will smooth them out. Next to these elements is a chip called a comparator. It serves to determine the power supply for the microcontroller. When you connect Arduino to the computer via a USB cable and at the same time connect the power supply through the socket, then the current from the power supply will pass to the USB port, that is, to the computer. All of this is extremely unsafe for both the microcontroller and the computer. For this reason, this chip will pass the voltage of only one of them. The priority, of course, is to use the energy of the power supply. This is all standard for ordinary Arduino boards, but in our case, if you connect Arduino to the computer simply via a USB cable, Arduino will not even turn on and the computer will not see the connected device. To protect the computer ports from damage, our version of Arduino does not consume energy from the computer, but only exchanges data. That is, using USB, you can only program and without additional power, you won't be able to turn on Arduino and program it. We will talk about how exactly to connect Arduino to an additional power source in the next lesson. Now pay attention to the plastic combs installed around the microcontroller. They are called connection pins. They are also divided into several blocks: power block, analog in block, digital pins block. First, look at the power block. In this block, all the pins are designed to work with power. Let's start with VIN and GND. VIN stands for V, volt, in, input, i.e. voltage input. Using these pins, you can supply external power in the same way as through the power socket, except that you do not need a connection wire plug to connect to these pins. For that, you need to connect plus of the power source to VIN and connect the minus of the power source to GND. After power is supplied, the power on indicator will light up, an LED indicating that the board and chip are turned on. Next, 5 volts and GND. They are used as an output with a voltage of 5 volts. That is, when you connect an external source to the power socket, 5 volts appear through the voltage stabilizers on these 5 volt pins, and this voltage can be used to power other modules and sensors. Similarly, there is a 3.3 volts pin that can be used to power some other modules that only require 3.3 volts. The last pin is the reset pin, which is used to hard reset the microcontroller. For that, it is enough to briefly connect the reset pin and GND. But for a convenient reboot, a button is installed on the board, by pressing which you can reload your program. Now let's move on to the digital pins block. These pins are digital and are used to communicate with other modules. They are all capable of turning on or off 5 volts at your command, independently from each other. For example, this way you can turn on or off the LED. Also, note the tilde sign next to some pins. This sign means that this pin has an additional option. It is called PWM. PWM stands for pulse width modulation. We will study these features in more detail in the following lessons. Let's move on to the analog pins block. These pins can work like the previous digital pins, but they can also receive analog signals. We will talk about this in more detail in the following lessons. For now, you should just know that these pins receive a signal not only as 1 or 0, 5 volts or 0 volts. These pins can accept a signal between 0 volts and 5 volts and determine exactly how many volts are coming to a given pin. This way, it is possible to determine the incoming level of the signal and not only the presence or absence of the signal. You should also note the reset button, which is used for hard reset of the microcontroller. After pressing it, Arduino will reboot and the downloaded program will start working again from the beginning. If you keep it pressed, then Arduino will not turn on and will not start executing commands. There is also a 6-pin ICSP contact on the board. This pin is used to download the firmware and configure the chip using external programmers. Let's now move on to the software part. We will start by installing the Arduino IDE. You can get all the programs and necessary files from the attached lesson materials or download from the official website. For that, you should go to the official website of the developers, arduino.cc. Next, select the software menu. In the page that appears, we need the download section. Here in the download options subsection, we need to select the version for your operating system. After clicking on this button, the developers offer you the opportunity to help them. It's just help and not payment for the program. The program is free. To start downloading, click Just Download. Choose where to save the file on your computer, and the download will start. When the download is complete, you need to run the downloaded file. The installation of the program will begin. The window that appears offers a folder for installing the program and driver files. A series of messages will appear. Message 1 is the license agreement. You should read it, and if you agree with it, click on the I agree button. Message 2 will prompt you to select the installation components. Leave it as it is and click on the next button. Message 3 will prompt you to choose the path to install the Arduino IDE. Click on the Install button. Message 4 informs you about the progress of the Arduino IDE installation, after which the message 5 will appear. It should inform you that the installation of the Arduino IDE is complete. You can close it. During the installation process, windows may appear asking you for permission to install drivers. At least 3 messages. Allow the installation of the drivers. These drivers will allow you to detect and work with Arduino boards connected via USB. This completes the installation of the Arduino IDE. The program icon should appear on your desktop. When you first start the program, you may receive a message from the Windows firewall about blocking access to some Java Arduino IDE network functions. Allow access. This window will not appear anymore. The Arduino IDE program window will open. Now you can write code and upload it to Arduino. But before that, you need to connect the Arduino board to the computer and tell the Arduino IDE program which Arduino board and to which port you have connected. After you connect the Arduino board via the USB port to the computer, you need to separately connect the Arduino board to the voltage source, since our board does not receive energy from the USB cable, but simply exchanges data. So, you should connect a power supply to the connector, from 7 volts to 15 volts. Only then will the on indicator light up and the computer will see the connection. Now, in the Arduino IDE program, you need to specify which Arduino board you have connected. For that, select the required board from the list in the menu section as shown in the following figure. Now you need to select the COM port to which your Arduino board is connected. For that, select the desired COM port from the list of available COM ports in the menu section as shown on the screen. Unlike other Arduino boards, in the list of available COM ports, you will not see the name of the Arduino board in brackets next to the COM port. In our case, you will just see COM1 and COM7. The question is, which of these ports is the Arduino board connected to? The solution is very simple. Disconnect the Arduino board from the computer and open the Tools Port menu. In the list of COM ports, you will see only available COM ports. In our case, only COM1. Now connect the Arduino board to your computer and open the Tools Port menu again. You should see that the list of COM ports has increased by 1. In our case, COM4 has been added. So, your Arduino board is connected to the COM port that has appeared. If you did not see a new COM port appear when connecting the Arduino board, then the USB controller of your Arduino board is implemented on third-party chips, and you need to install an additional driver for it. You can download this driver from the attached materials of the lesson. The driver is for CH340G chip. Don't forget to unpack the downloaded archive file. To install the driver, do the following. Open any folder on your computer. Right-click on the computer icon, select Manage from the context menu. The Computer Management window will open. Select the Device Manager menu. In the Ports section, you can see that the connected device is not recognized by the computer and a driver is required. We press the right mouse button on this device and select the item Update Driver. In the window that appears, select Select on this computer. Next, you need to specify the path where you unpacked the downloaded driver. You need to specify it inside the folder. Click Next and you're done. Now that we have figured out the Arduino board device and installed the necessary programs, we can begin to practice. After you have specified the type of Arduino board, selected the COM port, and written your sketch, the sketch can be uploaded to the Arduino board controller. For that, select the menu item Sketch Load or click on the button in the form of a circle with an arrow. If you wrote the sketch in a new window and did not save it as a file, then before uploading it to the Arduino board, the Arduino IDE will prompt you to save it. While uploading, you will see a status bar that will show the progress of compiling and uploading the sketch. If there are no errors in the sketch and it has been successfully uploaded, the notification area will show the amount of used and available Arduino memory. Above the notification area, the message "Done uploading" will appear. Once uploaded, this code will make the LED on the Arduino board blink. This LED is connected to pin 13, which we specified in the code. Now download the archive of libraries from the attached files. This archive contains all the necessary software libraries that we will use in future lessons. After downloading the archive, you need to extract this archive into a new folder. Now, the contents of this folder need to be copied to the folder Libraries of the Arduino folder. Congratulations! You have learned all the basics of Arduino. In the following lessons, we will take a closer look at other IoT board modules.